Hello, everybody, and welcome to today's webinar presentation, Modern Apps Enriching the User Experience with HTAP, brought to you by MariaDB. I would like to introduce you to our presenter, Roger Eisentrager. Roger has been working in IT for over 30 years. Roger has technical certifications in AWS, Oracle, Microsoft, and IBM. Roger has been working with Oracle software, Microsoft SQL Server software, IBM software and hardware, AWS, Azure, and Google software, as well as many others, partnering with clients to achieve a better overall solution for their business.
Let's jump right into the presentation. We will talk about data access and how that has changed the UI or UX, user experience, some real use cases, how that user expectations around data access has really changed. Then we'll do a brief use case walkthrough on today's call. The three main technical areas of the MariaDB hybrid transactional analytical processing or HTAP platform are the server. We use the term OLTP server, MaxScale, which is our proxy, and ColumnStore. We will talk about how all three and how they handle HTAP, how they enable, I'm sorry. User experience and data access. So when I say the term users, this is really an expansive area, and this could cover support analysts, developers, and business users. The first one is speed. How can we speed up access to the data? Gone are the days of submitting a report and getting the results in 15 to 30 minutes, or at least the expectation of getting the results in that time frame. Sometimes in the past, it could take a batch job a day or longer to produce its results. Now the expectation is less than a few minutes or even seconds. This is really driven by consumer and mobile apps that are becoming the new norm. This is also driven by the real business need to have those decisions, i.e. reports, quickly. This really then is driving the need for new agile, simple to set up platforms that also can run anywhere, private cloud, public, commodity hardware, VMs, that will support these new growing data sets. This next one I want to mention is the ability to do flexible exploration of your data. For me, this comes from the consumer space, like what we see in the slide. This is from a website here in the US for electronics. This website, the end user wants to explore the product catalog, but in the fashion the end user wants to explore it in. End users may want to search by brand, features, specific capability, user reviews, or availability of or a specific combination or ranking or order they're in. These consumer business sites like what you see above, and the many ways to search and order what you are looking for is now spilled over into the expected business internal applications like a ticketing application, internal support system, other like applications. You really don't want to be bound by a specific search or even two different search capabilities. Flexibility is now the key. So with data set growing, the changing IT capabilities are really being stretched unless you have already a system that will allow for this. The third point here I want to make is that the old IT archive strategy, where you archive some data, you move it, if not offline, to an export file or to another separate database system, that you would require a whole new set of reporting queries to access it now. Users want and expect real-time access to both kinds of data, historical and current data sets. Also, if you have new or altered records coming in and you want to see how that is impacting a long-running trend, the newer platforms must allow for this near real time. You want to be able to graph that sort of data that may alter how your next set of products may need to be marketed or altered to better align to those new data points. Aggregations and rollups are also needed in the same system. Oracle materialized views really do not work in these new environments because you must be able to allow for drill downs for the details of those new trends of data. So when you add up all three of these points, you really start to stress the old traditional approach. And today that might mean stuffing your OLTP system server with all these capabilities when it will likely eventually fail or not scale due to the growing demand of those data sets. So what is MariaDB bringing to the table that will allow you to attack these new requirements, capabilities in a scalable, cost-effective platform? So another view of this is to think about the kind of activities that you are performing on your modern applications today. So the lower left-hand corner is your core transactional OLTP activities. Basically your create, read, update, and delete, CRUD. MariaDB Transactional Server serves this purpose as well as many others, as most of you are aware, such as SQL Server or Oracle, typically using a row-based transactional engine for this need, often running in a single node with several replicas on other nodes or VMs for high availability. What it lacks is really to scale an MPP, i.e. massive parallel processing, and a columnar design to align to deep analytical needs is really not there. So as you move to the right and up, your SQL's access paths, high availability DR, and other aspects typically get more complex, sometimes more costly in terms of people to support those same systems. So what we talked about earlier in terms of query on historical or large data sets fall in that bulk query MPP bucket you see in the middle here. You are really not able to effectively index anymore using the old B-tree indexes, as scalability and law of diminishing returns can impact this. As you index more and more in an OLTP system, most DBAs or administrators are aware that the more you index, the higher the cost of doing updates and inserts on each B tree also needs to be updated and maintained. Then there is the true analytics at the top to the far right, where it includes even larger data sets. I would even clump in machine learning into this bucket. Star schema is typical here in this bucket. This is really the domain of dedicated data warehouse platforms. So now let's talk about some use cases. We already talked about retail to a smaller degree. So I went to CVS yesterday and got this receipt. This is a long receipt with many coupons. Based on just what I just bought and what I've bought in the past, but not only in the store, but also maybe from my phone or online. On my phone app, here I have several discounts based off my history. Now in this receipt, the purchase part is OLTP query. And all these coupons being generated is analytics query based off my past and current purchases. Promotions tailored to a customer's interest at checkout, in-store or online. Integrated across channels, online, mobile phone apps, in-store purchases, personalized email to customer. So data being accessed to figure all this out is a unified view of both transactional data and historical data. So a few real world use cases that MariaDB Platform is in use today and working very well is the Institute for Health Metric and Evaluation, IHME, OTC Markets Group, and Pinger. I will not talk a ton of detail about these three use cases, but in the case of IHME, it is supplying health data to several government agencies to fight the spread of disease as well as finding better treatments for those same diseases. Huge amounts of data being generated. OTC Markets Group for trade analysis is wide and deepening detail and analysis for real world trades going on in the world. Great example of leveraging MariaDB columnar technology combined with transactional server to do analysis of real time and historical data for quick and accurate trend analysis of trades. O2C is using several advanced features of the MariaDB technology, such as windowing functions, aggregations, and other like tools to help them bring them in their day-to-day business. Then there's Pinger, which is a telco. It is a vertical renowned for large data sets. They revolve around CDRs, called detail records. So it needed the ability to store large data sets, query on them in real time, and allow for growth at an economical price. This too is a great fit for MariaDB Platform that includes the columnar technology. Another thing that happens in telco is customer churn analysis to figure out why a customer left, or why an incentive was not working, or maybe why a customer did choose to come back. For what main reason? So let's move on and talk about the MariaDB HTAP platform. So as I mentioned at the beginning, there are three main core parts of the MariaDB platform. The first is the MariaDB Server, which is the transactional piece of our platform. It is widely distributed software that is part of many Linux systems today. It comes included with things like Red Hat. Highly scalable, but yet unlike others, we have smaller footprint, which allows us a greater advantage when used with container technology. Most of you know our MariaDB OLTP server can utilize several storage engines, which the most common is InnoDB. Our database server is the back end for a lot of worlds, websites, stores, businesses, and government applications. Lots of Fortune 500 here. MaxScale is the platform services for our clients and is a proxy layer. It enables HA, huge scalability, security, and CDC, change data capture. The CDC is important as it automatically moves data from the transactional server to the ColumnStore layer. We'll talk more about that later in this presentation. ColumnStore, the third component here, which is the analytics focused way of handling the data to enable large data sets to make sense for your business. It is a compressed columnar engine. In other words, the data is compressed, which enables you to consume less space and actually speeds up the way the data is accessed. It has built-in data distribution that helps address both HA, DR, and scalability. It has key data connectors technologies such as Spark and Kafka. Pentaho Kettle is another one. We're going to talk more about those in the coming slides. So moving on. This is really a pictorial representation of what was on the last slide. The way to think about it is on the top is what we have in terms of applications. And I'm using the term, again, applications loosely here. This could be analytics users, could be ad hoc reporting, could be mobile applications accessing the data. All of these applications are connecting through MariaDB MaxScale. And MaxScale really does more than just route queries, handle security, etc., but helps bring together both our OLTP and OLAP, ColumnStore, solutions into a single unified platform. And that is how the applications see it. MaxScale really hides the complexity of these systems with a little change in the application source code. MaxScale is a single connection string, and that is how it appears to the application front-end services. So as the data is written into the OLTP server, there's a CDC event that streams the data to the OLAP server, which reformats it into a columnar storage. In this way, MaxScale is configured then to route queries to either OLTP or to the OLAP servers, and this is transparent to the application layer. Also, this question does come up. It is not a one-to-one in terms of space requirements, as you remember that ColumnStore is compressed columnar. Thus, the compression can be as high as 90%, depending upon the data types, varchar, date, time, decimal, images. Lastly, in regards to this slide, is that you can run this whole platform on a number of architectures, such as bare metal, VMs, containers, or Docker images, or cloud. Before we talk more about MariaDB platform, let's talk about how the more traditional approach the doing analytics and moving of the data will sometimes look. Usually there is an ETL tool that is expensive that will pump that data into a data warehouse, or it may only copy a portion of the data. Also, this ETL movement is not usually in real time, and at best is 5 to 30 minutes plus behind the source system. Sometimes this movement of data is done nightly, meaning the data is 12 to 24 hours old. Also with these two systems, there tends to be an operational barrier where you will have two different groups doing administration and security of the old OLTP data and the data warehouse data. You can have vastly different tools used for the two data sets as well. However, if you were to have one platform that does hybrid transactional and analytics processing on the same data, your application does not have to go to different databases and can get instant, accurate analytics. This is where the MariaDB platform comes into picture. Let's talk about the OLTP DB server briefly. So we are the backbone of services used by people every day. When they're using Samsung smartphone cloud, fill a prescription at Walgreens, even at places where magic is created. Point in time, rollback, encryption. By the way, encryption is in flight and at rest. Oracle compatibility mode, and temporal tables. Now, all of this is not the focus of today, but it's something I really want to quickly draw out so that everyone know what are some of the capabilities of our OLTP server. The Oracle compatibility, I want to draw that out. When that mode is turned on, roughly 99% of all the PL SQL code in Oracle will come across with no changes whatsoever. Let's talk about MaxScale. So I called this earlier as our platform services layer, because if we limit ourselves by only saying that is a proxy or even just a database proxy, is then limiting what that product is all about. In the HTAP world, this is really a layer that binds all the other products together. Database proxy, replication server, and CDC components in MaxScale. We're going to talk more about things like schema sharding and offload replication in the coming slides. This is just an internal picture of MariaDB MaxScale that is showing most, not all, of the components we just talked about. MaxScale is a great piece of software that is easy to configure, makes DBAs, administrators, SEs, IT architects, and other jobs so much easier. Most people think of MaxScale in terms of the query and firewall portions, but it has a built-in database monitor. You can see this down below on the far right-hand corner, that is watching all the components and calls other modules depending on some event, such as a failover, a CDC event, or a session failure, etc. And it really is a critical component in terms of both the MariaDB OLTP server and the MariaDB ColumnStore OLAP server. Now, I kind of wanted to do a little bit deeper dive into the MaxScale and how it does routing queries. So MaxScale will define a listener and a port and is listening on to accept outside connections. And that listener is attached to a separate definition of a service. And the service is related to multiple servers. So those servers are those downstream OLAP nodes or OLTP nodes or replica nodes. Then using these three components, i.e. listener, service, and server, then using a predefined filter, you have the ability to do smart routing of queries, not only to the OLTP or even the OLAP server, but also you can route a set of queries to a replica, a read-only replica that is used for DR purposes. Now we have a couple examples of this, but in essence, you can leverage your replicas then to do reporting if you so want. Why keep those CPUs and not in use over in the replica systems? So one way to do this is to define a separate listener for only the OLTP connections. In this PIC, we have defined this to be a listening on port 4009. You can see it in the far left-hand corner in the box. And it's just an example. You can configure this any way you want. And it knows we have 3 servers for the OLTP server. OLTP server 1 would be the primary, and the OLTP server 2 and 3 are replicas that can be used for queries as they are in sync with server 1. Now at the MaxScale layer, we need to build the OLAP or ColumnStore component, and that's what we're going to talk about next. Here again, MaxScale for the OLAP, the ColumnStore component, is listening on port 4010. So this is a separate listener, and we have defined 2 OLAP servers, OLAP server 1, OLAP server 2. So here's where you may tell your BI tool, for example, Tableau, that when it connects to MaxScale, the MaxScale layer knows the application is a BI tool, and it will route all its requests to the OLAP listener. And depending on load or other components, the query being made by the BI end users may be fulfilled from either server 1 or server 2. Okay. Now let's put them all together, right? Let's now, we need a complete HTAP environment that will tie all these components together. So in this example, we defined one port 4011, but under the HTAP service, there are additional listeners, you can see those below, that will have additional filters that will have the capabilities to do the smart routing of queries. We can keep talking about that. We have several choices about how we do those query routing. Okay. For example, you could, at the top layer of this HTAP service layer, make the query routing based off hints in the actual SQLs being submitted into the MaxScale product. This is not transparent, and you're giving the SQL writers the capability to selectively push a set of queries to either the OLTP or OLAP servers. Sometimes we see this where by default all queries will go to OLTP, but if the MaxScale HTAP service sees a specific hint, it will then push it to the OLAP ColumnStore server. Sometimes the opposite is true, where a particular BI tool we know all, or almost all, queries will go by default to the OLAP ColumnStore server. But there might be 1% or 10% of the time we want the few queries being fulfilled by the OLTP server. Keep in mind, you do not have to use hints in the SQL statements for redirects. You can also, in the MaxScale configuration, to redirect based off a particular schema, owner, or even a set of tables. You can also redirect based off a specific SQL attribute, like a group by or other. This can be very useful here too. So here's the example of a hint filter, where on the left is the SQL and where no hint is used, and on the right, a hint of MaxScale route is used. Actually, MaxScale route to analytics. Personally, I don't, when using hints, I tend to like to keep these a little smaller, but this is a good example. Here's another example of where the reroute is based off the clause and what sort of attribute is being passed into MaxScale. All right, so in this example, it knows that table purchases, for example, all of those will be routed to the transactional server, and anything that includes the view purchases history, that will be rerouted to the analytical database. And this example, we combined it, and we're showing the rerouting in action. All right, so you got several filters in action here in this example. So now let's talk about the ColumnStore. Those coming from the transactional database world, this is relatively new in terms of delivering fast results without the need for a lot of people resources or a large amount of CPU's cores as compared to the past ways to deliver the same results. two core capabilities of ColumnStore. One, it stores the data in different format as compared to transactional databases. Data is stored column by column. The second capability is the ability to run in a distributed fashion that allows for both MPP, massive parallel processing, and for high availability. The data is spread across multiple nodes, and it has excellent compression ratios, as we talked about earlier, some as high as 90%. Okay. This pic is a simple diagram showing how ColumnStore is split between a user module and a performance module, i.e. PM. So we have a UM and a PM, that's what we call them. The UM is where the parsing of the SQL would occur, along with many other things, and it makes the decision to which node or sets of PMs or data nodes to access to pull what it needs back. I already mentioned the UM and PM nodes, but here it is showing a little bit better. We typically call the UM the front-end module and the PM the back-end module for the ColumnStore server. This diagram is a simple set up of a single UM and a PM. We call it S1 and S2 in this example. But how we look at it if we have several PMs or one or two UMs? Let's go find out. So this diagram is showing what ColumnStore typically looks like. I think it's easy to see that you could add more PMs on the far right-hand side on the bottom. So you have S2, S3, S4. But if you wanted to expand it, let's say you're adding more data, it's very easy then to add a couple more nodes. Let's call them S5 or S6. And then you would actually redistribute those new nodes and the data sets. This diagram is an example of executing a query, and the UM is consulting all three of these PMs to service the SQL results, all right? Especially the average, yeah, in this example. The diagram here is showing the ability to have more than just one UM and multiple PMs. I do typically see 2 to 3 UMs, and then I'll see several PMs to service those. But again, it depends on your data size, underlying hardware, and other factors that would fit your particular business needs. Okay. This slide is really showing how ColumnStore eliminates certain data points in a SQL statement. So as you add more and more rows to a specific table in ColumnStore, the database will break it up to multiple files called extents. There is metadata about those extents, i.e. data dictionary, that then is exposed to the SQL parsing layer, the UM, that then knows not to even look into that particular area of the table, the extent elimination, saving a great deal of CPU and disk I/O cycles. This is basically what this slide is showing. The last picture here is showing where MariaDB Platform is not a closed platform. It is an open architecture designed for multiple technologies to import data into it and multiple different technologies to access it. Can I load data directly into the ColumnStore using different adapters? Absolutely yes. This diagram is only showing a few. There are many others which can be found on the MariaDB website. So that is the whole presentation. Before we get into the Q&A, I wish to point that I'm on LinkedIn, and if you search my name, you can easily find me, and I'm happy to connect to you if you could send me an invite. We have a lot of time actually for questioning, and I will do my best to answer them. So I will take a look at Q&A widget, and I will give you a minute or two to submit a few more.
Great, Roger. Thank you so much. We do have a few questions that have come in. The first question that we have is it possible in MariaDB transactional server to address point-in-time recovery?
Yes, it is. In fact, yeah, It's very easy to do. It's called flashback. And you can even, not only can the data be point in time recovery, but let's say you're failing over from to a replica, for example, from the primary, and anything that's in flight at the MaxScale level, those transactions also would be failed over. So the sessions are actually failed over. Any other questions?
Yes, we do have a few more questions. And audience, like Roger said, if you do have any questions, please post them into the questions panel. The next question that we do have is, if MariaDB ColumnStore is so large, is it recommended to run backups on it, or do you recommend we simply run a rebuild from the transactional server?
It depends on the size. So I have several clients that run ColumnStore, and some, especially when they get into the petabytes layer, multiple terabytes, they really just build off of the transactional source side. So yeah, it depends would be the right answer. And I know that sounds like a cop-out almost, but that's usually what I see in my background.
Great.
So it depends on, yeah, any other questions at all, Billy?
We do have one more currently. That question is, could the MariaDB ColumnStore be used as an archive target instead of holding years and years of data in the transactional MariaDB server?
Oh, that's a great question. In that example, and there's two ways to do that. In OLTP, the source system, you could actually partition a table by date time, and then you could actually pick up the partition or use CDC to target those date times. Let's say it's a year, a month, and then copy that, use it into the ColumnStore, and then keeping it there. And that's for twofold reasons. One being you're archiving the data into a mode that you still can report off of it, and the other, you're saving some space. Okay.
Great. Since that is all the questions that we do have, Roger, is there anything you would like to add?
Not at all. I want to thanks for everybody's time, and thank you, Billy, for the introductions and setting this up.
Of course. And I'd like to thank you, Roger, for a great presentation today. I'd also like to thank today's sponsor, MariaDB, for providing the audience with a wonderful webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day, and we'll see you next time.